So during this demonstration, we're going to be looking at the new BlazeMeter continuous testing platform. We've extended the market-leading BlazeMeter performance testing with functional UI testing, API testing, the ability to generate and utilize mock services, and also API monitoring. So let's get on with the demonstration. So we've now logged into BlazeMeter. Along the top of the screen, you can see the various tabs where functional, performance, mock service, and API monitoring. We're going to start with functional. So what we need first is a test. So we're going to use the Chrome plugin to actually record a test. So this is our digital banking application that we're going to use for demonstration. And if I click on the plugin, I've already recorded a test. So I've gone through a scenario where I've logged in, I've done something and logged out. And I can show you that by rerunning the recording I've made. So if I go to the editor and we just open that recording, I can click on the play button, just make it a bit quicker, and that'll replay the test I've recorded. And what you'll see here is we're going to the landing page, we're entering the username, we're entering the password, we're submitting, we're then going to the Visa Direct part of the application, and we're going to select our bank account, enter a value. Now what comes back is a status, and that status coming back from an API, and we're confirming that status is correct. In this case, it's saying insufficient funds, and then we're going to log out. So at this point, we know we have a working test that we can reuse. We can extend it, we can further edit this. If I go back to my plugin, what we also have, as well as that test I just showed you, at the same time, we've also recorded a performance test using JMeter, an API test using JMeter, and also an end user test, which is JMeter and Selenium. So we could just click on these and automatically that will run those tests on our platform. But what I want to do is to save them and then show you how we can manually load those into the platform. So all I've done is gone to the save and I've saved these files. So if I go back to BlazeMeter, let's create a test. So we're going to click on create test. We're going to do a GUI functional test. We then click on the upload script and it points to those scripts that I've saved from the recorder. Now I modified the script slightly to add a dependency. So that dependency is that for us to be able to run this test, we actually need a mock service to run, and that mock service needs certain transactions. So within the actual script itself, you'll see here it says dependencies. I've defined that I need the Visa payment template to be active. And at the bottom of the screen, you can see that mock service is now assigned. It's currently running. And at the time of us running the test, we'll actually load our transactions into that mock service so that when the UI test makes a call to that API, it will respond with the transactions that we require. Now, if I rename this test, so we're going to call it our debank UI test. I can click run to run. I could schedule this to run it on a schedule, but we're going to just run this. Now, while that's running, what I'd do is I'd go and look at an existing one. So let me click on run test again. So that's running. So let's go and look at one that we ran earlier. So what happens is when the test completes is you get various data. So one is you get video. So here's the video from the previous run. If I make this full screen, you'll see this. So this is the output from the test that's run on the platform. And what we're doing is we're going to that site. We're going to log in as that user. And we're going to follow exactly the same steps as you saw in the plugin when I run it locally. We're now running it on the cloud platform. So that's the user logged in. That'll be the password. Now what we can also do, as well as the video, we can also navigate through the controls. So while that's running there, let me just come back out of this. We'll pause the video. Now on the right hand side, these are all the steps that we ran for the test. So if I go into this check visa status and I click on that, this will take us directly to that particular part of the test. So we can navigate the output. Now obviously everything passed, so this is a good test. We can also go to the waterfall and look at the response times. So these are the different tests that we ran, and for each of those we can also get all the status and the data on that. If I mouse over these, you can see we get all the data for that request. So we've got all the metrics to understand the performance of that test. Now we can also create API tests. So if I go to the API tests, Now, like before, I can just import the tests. So down here, I could import using the JMeter script that we created during the recorder. I can import a Swagger file. And the idea of this is that a developer, perhaps the API doesn't exist yet, and that definition has been created inside a Swagger file. We can load that in to add it to our API test. And if I go and look at one of the tests that we already ran, the output of an API test is like this. It shows you each of those endpoints being tested, the response time, any assertions we created, and all the details on the test. So at this point, we've actually, from the plugin, we've managed to generate a UI test and an API test. Now, wouldn't it be great if we could take that UI test and run it with our performance test? And we do that in the performance tab. So we click on the performance tab. If I go to the create test, as you can see here, we're going to create a performance test. Now, like before, we can just upload the script. So if I click the upload script, this time I'm going to select the combined script. This is a JMeter and a Selenium script. And we're going to click open. Now the script type is Taurus. This is CA's open source standard that we use for testing, and that allows us to combine these JMeter scripts with Selenium. Now, like before, I've also updated the script to rely, because we rely on this dependency to be there for the script to run. So as the script is loaded, which is just done, we've defined that this is our JMeter script. If I scroll down, I've also loaded the mock service as a dependency to ensure that those APIs are available when the test runs. We can also go to the end user experience and enable the end user test that we want to run. So as we generate the load test, we can automatically run UI test at the same time. We can also then go and actually enable things like APM. So we're going to use the CA APM. So the reason we do this is that when we generate the load on the front end, we can also gather data on the back end systems using the incumbent APM tool. Now this is the CADX APM tool we're using here, but as you can see, we support many third parties. The main APM tools in the market are supported as well. Now we could modify this test further to change the way that we emulate a network to perhaps generate a slow performance. We can enter failure criteria, so what makes a good test pass. But in our case, what we're going to do is just name this test. So UX and perf test. Like before, we could schedule this, but we're going to run it. Now, when we actually run the test, the first thing you'll see when we're running the test is the first thing is setting up those test dependencies. So those test dependencies in our case is the mock service. We're making sure that mock service is running and that the transactions that have been defined inside the test are available. Once we have that working, we're then going to stand up our load generators, and that's the ones here. Now in our case, they're all being loaded in North America. Those load generators can be from anywhere in the world on any platform. So they could be Amazon, Google, Azure. You choose where the load generator is going to come from. Now, while that test is initializing and running, let's look at one that we ran earlier. So this is the same test that we ran earlier. And on the initial screen, what you're seeing is a standard BlazeMeter screen that shows you we simulated 21 users. We ran the test for 16 minutes. We have an overview of the response times. Down here you can see now the blue bar is the users. So we ramped up over the first minute the users, and then we've got the response times and the error rate and the load that we generated. Now if we drill into further into this test, if we click on the timeline report, we also have lots more data. So if I on the left hand side just collapse this slightly, if I go to response times and I look at the response time for the Visa payment. So the Visa payment is actually when we click on the button in the application to submit the Visa request, we're making an API call to the external system. This is the response time. So what we can see is that we actually had quite a poor performance at a certain point. So we obviously need to investigate that. So if I scroll down further and we look at the APM data, so when we're looking at this CA APM, this data is coming from the APM system monitoring the system that hosted the application server. Now I can enable some metrics here. So a couple of useful metrics are obviously CPU. Now what this shows me is that the CPU on the back-end systems wasn't particularly overloaded at the time we saw the response time issue. So we can infer from that that the infrastructure itself wasn't under particular load. There are many other metrics we can get from APM. We can get metrics from the database and various other components, so we could drill in further. But at this point, we're going to assume that the back-end infrastructure is working properly. If I go to the top here, this section is showing me the UI test that we ran. So where I just clicked on that and the yellowy dots has appeared, each of those yellow dots is a UI test that was running at the time we generate the load. So if I go and click on one of these dots and drill into it, we can see the response of that particular UI test. So as you can see, everything was normal. Then at this point here, suddenly we start to get a poor performance, and that carried on for a while. Then it went back to normal. If I click on one of these, like we saw in the performance test, the functional test, we have screenshots of the actual test itself. So we actually see what was on the screens as the test was running. But also, more importantly, at the bottom, we again have the waterfall details. So we can scroll down to look at the data that came back to understand where that delay was. And as you can see there, when we did the visa post, so it's actually making the call to the API, we had a very slow response coming back. So the API itself was performing badly at that point, which caused that end user experience issue that we saw. Now for our demonstration, what I actually did is I made that API perform badly. So we're using what's called a mock service to simulate the API, and we can then control the response time that comes back. So let's go and look at what a mock service is. So I've just clicked on the mock service tab, and we're now looking at the mock services. So in my example, I've got a running mock service, which is just here. Now that mock service has an endpoint, a URL. So we've configured our test application to point to this mock service. So whenever the API makes a call to the Visa API, it's actually sending it to our mock service. Now our mock service has down the bottom here what we call transactions. So we've loaded in the transactions that we want that mock service to apply to. So these are tagged, these little blue fields are what we call tags. So in this example, this one would be an approval. So if we sent a certain request, we'd expect to get back an approval response. We have insufficient funds, we have various other ones. Now we can control what's in this mock service, so we can actually move these backwards and forwards. So we can load transactions in that we need. Those will be loaded by tag or by what we call a template. So you can define how that mock service is going to respond for your testing. So the next question is, how do you get a mock service? If we go to our landing page, we can just upload files like Swagger, HAR is a recording you can do in the browser of APIs. We can get WireMock and MockLab imports as well. So as an example, if I click on this, we're going to point to a HAR file that I recorded. So all I did is I've gone into the browser, I've recorded some APIs and just saved it as a HAR file. And what that's done is that's then built me a mock service. So here's the mock service here. It will contain that transaction that I recorded. I could, at this point, could just click run mock service, and that will then start me an endpoint using that transaction that I can then use for my testing. Now we talked a bit about the transactions. If I go and look at our transactions, these are the transactions we have. Now you can actually group these in what we call into services, so they can be easier to work with. If we look at this example here, what we have is that's the name. What we're saying is that when we get a request on a certain URL with a certain payload, so we're asking for an account number and a value. So in the application you saw we selected an account and entered a value we want to transmit. We're saying here when we have an account and a value, we will have a certain response. Now this response is actually the response from the Visa API. So based on that response, we can have different scenarios. So in my example, if we enter a certain value, we'll get back an approved. If we enter a different value, we'll make it an insufficient funds. Another value, we get a denied. So the mock service is clever enough to take the input from the request and match it to the relevant transaction, and then send back the relevant response to match the test you need to run. Now at a much higher level, so if we go back to the mock service, we could actually do things like, if we don't match something, we could forward it onto the live system. So it could be that you make a request to our API. Obviously, we have our transactions. If none of those match, you could forward that request directly to the actual Visa Live API service. Now, the reason that you would use a mock service is that perhaps the APIs aren't always available. You want to do negative testing. It may be that using the API is a cost. So actually making transactions, you'll get charged. And obviously in development, you may not want to keep on paying for a developer to test the API. So the mock service allows you to replace that endpoint with this mock service. And the other thing that a mock service allows you to do is actually to change the think time. So inject a delay. So when we looked at our UX performance, we had a poor performance because the API responded slowly. I'd actually come into here and actually defined a think time, a delay. So any request coming to our mock service would have a delay of several seconds. Now you saw that the actual end user was impacted by that because the API responded poorly. Now to the end user, what they saw was that my application responded poorly. Now behind the scenes, that was the API. So my customer is getting a bad experience because of a third-party API that is performing badly. So how can we then manage those APIs to make sure that the APIs that we rely on are working and also responding correctly? And the answer is we use our API monitoring. So if I click on the API monitoring tag, we're now looking at the API monitoring, and we've set up monitors to monitor APIs. So one API we're monitoring is the actual Visa API. We're also monitoring our own internal APIs to make sure our servers are running. Now, what this allows us to do is several things. Now, an external API may be something that we're paying for, and we need to monitor it to ensure the SLA is working properly, and also that the API is working, that we rely on it for our customers. We can see here that the little green bars indicate that the test is passing. If I click on a red bar, that shows the test failed. So if we go to that test there, what we can see is that we made a request to an API. It actually returned an invalid. The actual response was okay, it's a 200, but the actual body, the response that came back, didn't match our test. So there's an issue with the API itself, hence why we marked the test as being bad. But also, if we go and look at overall for all that test, so we can look at for this API over the last 24 hours, we can look at how reliable it's been. So it's been generally reliable, but also we can look at the response time. So how has that API been responding over the last 24 hours? Have there been any issues? Obviously, we can select this and look at a longer time band. Perhaps we'll look at the last 7 days. So you can look at how that API is working. We can also go and look at, if we look at one of the other tests. So this example here, we were looking at our API within the application itself. And here are our test results. And like before, what we've got is our request. Now also we can link this in with our DX APM tool. So as well as actually getting the data from the API, we could link to the APM tool to get status from the back-end system. And finally, obviously, how do you actually get these API tests? So you can actually import these tests from various sources, including things like the CA API gateway. So we can get the APIs we actually need to run here from various sources to make it very simple to set up this API monitoring. So what I've just shown you is how we can actually record a UI test, or record a test in the browser, and then reuse that for our UI API, our combined UX and performance tests. How we can then use a mock service to replace the service that may not be available, an API that may not be available, and also then further monitor those APIs, not just in our test and development environments, but all the way through into our production environment. Thank you.